Lecture 29, Profiling and Scalability. Following our discussion on profiling, we're actually going to transition a little bit from here to the subject of scalability. This topic kind of sits at the intersection of a couple of things, and so it makes for a nice transition from one to the other. We're going to talk a little bit about profiling, but really where we're going with this is the scalability side of it, because that will be where the remainder of the time in the course topics are going to be spent. Our intention is to make it so it's possible for your goal, for your program, your application, whatever it is, to scale based on the number of users. So, in the beginning, you only really have to support one. It's your test user. You give it a try. You see how you do, and over time, you will expand. You hope you get more customers. You get new users one way or another, and ideally, in the end, you can get to, well, it's 10 million on there. Could be more. Don't limit your dreams based on what you see in this slide. Go for broke. Okay. If you want to figure out how to do that, some of the things that we'll need to do, we'll discuss the idea of just being fast. That's not our only option. We'll see later that sometimes dividing up the work amongst multiple machines is going to be actually our best approach for getting some stuff done and making sure that we are able to achieve the large number of users that we want. But we have to talk a little bit about some of the things that will matter when we want to get away from just working on something on your dev machine or your demo system, like where you could easily run 100 users, or even your first production system. If you have a lot of hardware at your disposal, or you can rent the appropriate hardware. But yeah, in the words of Billy Idol, in the midnight hour, she cries more, more, more. Okay. I know I've made this joke before, but yeah, the most interesting man in the world. I don't always test my code, but when I do it in production. And there are a few principles that we should respect when we are thinking about how to transition from your development environment to a production environment, and scaling up your production environment. 3 things that are important to us. First one is that scalability testing is distinct from QA testing. Although I will assume for the purposes of argument that you actually in fact test your code, you might do development on your local computer, run the unit tests on your computer, build it on the continuous integration system, anything like that. But your primary concern is it right? Does it produce the correct result? Are the tests green? Does it pass? And, is there something that is fast enough? That gets kind of a secondary consideration, if anything. All that you really care about is that it doesn't take too long to run your unit tests, because that slows down your cycle of, develop, run the tests, commit it to master, and on your way. That's okay, but it doesn't actually test if it scales, right? The scenario that we're working with is not realistic. If you want to know what, say, the maximum number of transactions that can be processed concurrently is, you won't find that out on your own machine. Low-end systems have different limiting factors. Your laptop maybe has 16 gigabytes of RAM, or 4 gigabytes of RAM is actually what's in the notes, but the slides are a little more up-to-date. Production server has 128 gigs of RAM, or 64 gigs of RAM, in which case it doesn't matter. So if you were trying to see how many users can I test with concurrently on my own laptop, you wouldn't end up with the right answer, so to speak, because you would be looking in the wrong places. You would say, we're limited by RAM, and we have to find a way to reduce memory consumption, even though it won't matter all that much, because on the production system, you have much more RAM, 5 times as much, or 10 times as much, or something. So don't sweat it. Reality principle. This is one of my favorite tweets about software testing. A QA engineer walks into a bar, orders a beer, orders 0 beers, orders 9999999 beers, orders a lizard, orders -1 beers, and then a cat walks on a keyboard. First real customer walks in, and where the bathroom is, the bar bursts into flames, killing everyone. That's quality assurance. Okay. It is it is necessary to use a real workload or as close as you are able to simulate. Legal reasons might prevent you from using actual customer data to test with, but if you can do something like anonymize customer data and test using that, you'll get a much better outcome than just whatever is in your staging environment, which is whatever development garbage that people have put in there over time. So if you limit your test data and your test scenarios, you don't necessarily get a representative view of what is going on. In your test database, there might be 100 companies, but in the production database, there are 100,000 companies. And so something that iterates over all companies is done very quickly if it's in the production, in the staging database, but is very slow on the production database. And you wouldn't know that. By that same token, you might discover that users do expensive operations much more in reality than you were expecting in your test set. Users, you might imagine, we do a summary report at the end of the month, and so that's not a big deal. And if it slows down performance of the rest of the system, it's not a problem. But sometimes users run summary reports every hour. This happened to me one time. Somebody was doing the summary report every hour because it told him what are my employees up to. How do I know what they're doing? I don't know that this is necessarily a good way to do it, and it's not. I don't think it was intended, and I don't think it was something that anybody recommended. But it gave him the information he was looking for, so I don't think he minds. And the third one is volume principle. More is the new more. It's okay to use light workloads for regression testing and anything else, unit testing, something like that. But of course, to see how your system performs under pressure, you actually have to put it under pressure. You can simulate pressure in a few different ways. One is, if you have a big enough workload, then that's great. But if you don't, you can pretend by doing something else alongside it. For example, limit RAM. If you've got control over the physical hardware, open up the box and take some RAM sticks out. See what happens. That will give you some interesting information probably about what happens when RAM is limited and how much swapping and what have you takes place. Run something CPU intensive concurrently. Do a video encoding when I do these lectures. I generally don't record them at the same time I'm encoding them because they're both intense efforts. And if I wanted to see what would happen to the recording software, I would do it at the same time as I do the encoding, and it would probably be noticeable. You'd probably get there's a lag when I stop recording to when the recording actually ends, or some other strange behavior. It would be interesting. You could find that out. However, those things are not just the same, right? It's not the same as if your application is actually using a lot of RAM to just go to the box and take out some RAM, or go to its configuration in your Amazon console and say, actually, we need a smaller instance, please and thank you. Those things work. They give you a simulation of what happens when resources are limited, but the answers that you get might not be exactly the same as they would be if you were actually limiting it for real. Just as an example, if you're running something very CPU intensive concurrently, that CPU intensive thing might get its priority downgraded by the operating system, such that it leaves more priority and more time for other CPU intensive programs to run. So you're not applying as much pressure as you thought, and moreover, being under CPU pressure is something that you worry about in your program, meaning that your program itself is the one that's getting the CPU limiting by the operating system. So you don't know, and you will find out better from a real test, but it's not to say that simulation is useless. The other motivation that I want to give you is that anything you can do that can demonstrate the scalability of your system is of interest to your customers and or management and or investors, because you are demonstrating that when it comes down to it, your system can take the pressure, it's well built, it's well made, you can deliver, and your system being reliable counts for a lot. Not everybody in management agrees with that. Sometimes people are really all about the features, and they insist upon, we got to have the newest features, and it doesn't matter if it's buggy. Not true of everybody, and ultimately, I think users have a bad experience if you don't give this sufficient priority. Okay. With those principles in mind, there's a follow-on point to that about reproducibility and regression testing. And as you will recall, from, I don't know, high school science class or something, or maybe even elementary school science class, the first rule of science is we don't talk about. No, wait. The first rule about science is results need to be reproducible, and that is just as true for any performance test as it is for unit tests. Right? You run your unit tests, they should be reproducible, they should be consistent. It should not be the case that running the unit test again 10 minutes later and because of some non-deterministic factors, we somehow end up with this test fails, and your strategy for getting around that is, no, it's cool, I'll just rerun the test repeatedly until it passes. Admittedly, sometimes during an emergency you have this problem and there's nothing you can do about it, and in one case, recently I had to rerun the build 9 times before the dice fell in my favor for a flaky unit test to give me the thumbs up. But that's not the flakiest test I've ever seen. One time I changed the README. None of the code, just the README. It was about giving better instructions about how to launch the application locally without requiring a different service to also be running, and that caused a unit test to fail. And that is, well, I won't say my favorite, but certainly the most salient example of a flaky unit test. Anyway, just as we don't want to see old solved performance issues coming back, we don't want any new change to slow down the program a lot, and so there should be tests that watch for this and fail if things got much worse. Right.